All right, welcome to this highly anticipated explainer. Today, we're completely demystifying how the Kimi K3 system can basically act as your own personal builder team. We're talking about taking a single plain English prompt and turning it into a complex, fully functional digital product. If you've ever felt bottlenecked because, hey, maybe you lack coding skills or 3D modeling experience, well, this explainer is going to show you exactly how to smash right through those barriers. So, here's our roadmap for today. We'll quickly map out the Kimi interface, look at the AI building loop, check out 3 epic AI builds, break down the anatomy of a perfect prompt, explore how to control software with MCPs, and finally, go over some golden rules for AI builders. By the end of this, you're going to shift your view of AI from just a simple chatbot to a powerhouse software operator. Okay, first up, the Kimi interface map and finding your way around. Before you direct a team, you kind of need to know the controls, right? So almost everything we'll talk about today happens right inside the primary terminal, which is Kimi Chat. But the ecosystem goes a lot deeper than that. You've got Kimi Work up on the top bar for organizing your finished projects, and the dashboard on the left for plugins and web extensions. For specialized tasks, My Kimi lets you build custom assistants with unique memory. And for the heavy lifters out there, you've got Kimi Code, that's the developer route connecting to external software, and Kimi Claw for connecting open source agents. Basically, it's a complete workstation. Next up, the AI building loop, or how to go from one single prompt to a published site. Now, this loop is wild because it takes a process that honestly used to take days or even weeks of coding, hosting, and debugging, and just distills it down to 4 incredibly simple actions. Step 1, you write one detailed prompt. Step 2, Kimi writes all the underlying code for you. Step 3, you actually play and test it directly in your browser. And step 4, you publish it as a live site with a single click. This exact 4-step loop was run just once to create the mind-blowing interactive builds we're about to look at, and it publishes them instantly to a shareable kimi.page link. Let's dive into Section 3, 3 epic AI builds, from roulette to open worlds. Let's actually move to the showcase and see exactly what this loop can produce. Seriously, prepare to be amazed by what a single prompt can generate. Our warm-up build produced a fully functional 3D European Roulette Wheel. And we aren't just talking about a static flat image here. Kimi used Three.js to build a spinnable, photorealistic wheel. It placed all 37 pockets in the exact mathematical order. You can actually flick it to spin, and the physics engine makes the ball spiral inward mathematically before bouncing and landing on a correct number. All of that from one prompt, wrapped into a web link. Crazy, right? But let's take it up a notch. The main event gave us a project called Sunset City, which is a fully playable Grand Theft Auto-style open-world game. The prompts just asked for freely available assets and similar gameplay mechanics, and the result? It's a city where you can run around, press E to enter cars, drift around checkpoints to collect money, and even earn a wanted level if you cause enough trouble. You'll even see smoke pour out of the car when you crash. It's an entire multi-part, interactive environment generated completely by AI. Now, a project like Sunset City only exists because of K3 Swarm. See, standard K3 acts like a single worker. It does task 1, finishes, then does task 2. That's great for, basic research or chat, but K3 Swarm spins up a parallel team of agents, kind of like a swarm of bees. It tackles physics, rendering, UI, and gameplay logic all at the exact same time. If you want to build games, apps, or complex multi-part projects, you absolutely need that parallel swarm working for you. Our final showpiece is truly a jaw-dropper. Built in just 2 prompts, we got an exploding 3D electric guitar. It generated this sleek black and white guitar where you can drag a slider to literally explode the model into its individual parts. You see the pickups, the coils, the truss rod, the tuning machines, the internal wiring, the whole shebang. Drag the slider back and it snaps perfectly together. And best of all, you can actually click and pluck the strings to hear real notes with a proper electric guitar tone. No way, right? All right. Section 4, Anatomy of a Perfect Prompt and Why You Should Absolutely Steal This Framework. Seeing those builds naturally leads to the big question. How on earth do they get these results? Well, the crucial point is that a successful prompt isn't just a long, rambling paragraph, it's heavily structured. Step 1, name it specifically. Don't just say casino game, say European Roulette Wheel. Step 2, correctness. Add checkable constraints, like all 37 pockets in the correct order. Step 3, motion. Describe the physics, like ball spirals inward or fully playable. And finally, step 4, container. Dictate exactly where it must live, like in a single HTML file or in Blender. If you hit these 4 beats, your success rate is going to absolutely skyrocket. Moving on to Section 5, Controlling Software with MCPs, or the Blender Bridge. So that 3D guitar we just saw, built by someone with zero 3D modeling experience. How? Through an MCP, or Model Context Protocol. Think of an MCP as a universal translator. You type in plain English, and the MCP converts your intent into the highly complex, specific actions required by external software. In the case of the guitar, the Blender MCP allowed Kimi to directly edit, arrange, and render 3D objects inside the Blender software without the user needing any technical modeling skills whatsoever. It's a real game changer. The impact of this is absolutely massive. To put this into perspective, if a beginner tried to model that exact guitar by hand in Blender, they're looking at 40+ hours of pure frustration. Even a pro needs about 8 to 12 hours. But combining Kimi code with a Blender MCP, it literally takes minutes of AI effort. You just describe it, and the AI drives the software. Finally, Section 6, Rules for AI Builders. Let's talk open versus closed models and some best practices. To wrap up this explainer, let's establish a bit of a builder's rulebook. The crucial point here is knowing when to use which tool. You're going to want to choose open models like Kimi when you want lower cloud costs, local hosting, and total customization freedom. But you should pivot to closed frontier models when you strictly need maximum speed, raw capability at any cost, and absolutely zero setup. Let's run through our final set of operational rules really quick. Remember these best practices. First, detail always beats length. 1 or 2 sentences with sharp constraints will outperform a vague one-page essay every single time. Second, match the mode to the job. Use single agents for research and swarms for complex builds. Third, understand that MCPs turn AI from a conversational bot into a literal software operator. And finally, publish everything. A build that lives on a published web link gets shared, tested, and improved. A build that stays in a chat window, it dies the second you close the tab. So now that you have the complete blueprint, the interface map, that 4-step loop, the exact prompt anatomy, and the knowledge of MCPs, you possess the power to turn a single sentence into a published interactive world. The old bottlenecks are completely gone. The only question left to answer is this: what will you build now that an entire team of AI agents and software operators is just one prompt away?